Yeah.
Yeah.
Okay. All right. So let me share my screen. Okay. The materials for today's practical already shared. Yeah. Under lab practical, week 6 is configure NAT for IP version 4. Right. So week 6, configure NAT for IP version 4. So we are going to practice what we've learned during our lecture. And for homework, right, it's also on NAT, investigate NAT operation, then configure static and dynamic NAT. All right. So that's also shared already. So let's just have a look here. All right. Week 6, the 3 packet tracer here, yeah. Configure dynamic, configure static, and investigate NAT operation. So these are your homework, yeah, homework packet tracer. So this week, lab is this one, only one, yeah. This one, configure NAT for IP version 4, right? Okay. Okay, so download those, and then we'll talk about the our lab for today. All right, so this is the topology that you have to create. What you need is the two switches, two routers, and two end device. Okay, two PCs. Addressing table is given here for all the devices. Okay, so as you can see, yeah, for R2, notice this one is loopback interface. You have to create a loopback interface for R2 and given these addresses and address and subnet masks. Okay, so the first step you need to do is to basically go to your create a new packet tracer file and create this topology. Right. All right. So our objective today is yeah, for here, yeah, is first part is to build our network and configure basic settings, right? So this one is standard lah. We've done this many times already. Okay, basically just drag and drop to create exact topology here that you see in your packet tracer, and then configure some basic device settings, which will be given down in the pages below. Yeah. After you complete part one, then we'll go straight into configuring NAT, right? Network address translation, okay, for IP version 4. Then once we verify that, we configure and then we verify that it's working, we go to part 3. And for this one, almost the same, but the only difference is overload means we will use, we'll do a setting for PAT or PAT, that is port address translation. That means we will be using a combination of inside local address and the port number for the source application, right? So that we can is to provide us unique ID to map, right? To map host to the inside global, right? Inside global. If we have a pool, we still have to map, or in the case of home user, we probably only have one, okay, inside global. So that means we need to the router needs to map between the inside local and inside global, so that because we are sharing the in terms of only one IP address inside global, then we are sharing that. Okay, all the devices will share that. All right. So finally, we'll be doing configuration for static NAT. Okay, for part 4. Right. So this is the background. So read through your background. Right. I think basically talking about what I was talking earlier on. Okay. So just a little bit more detail. So go ahead and read. Right. So required resource, as much as possible, try to drag in the routers with the and switches with a similar model number. Okay. Right, so part one, build, network, and configure basic device settings. Right, so create your topology, provide the straight-through cable to connect all your devices, and then just do simple configuration. So there are two routers, so you duplicate, okay, the exact configuration on each router. Of course, in terms of host name, right? Host name you differentiate lah. The one router is R1, one router is R2, right? So basically, these are just the basic configuration that you just do it lah. So if you save the list of command, but before you just customize it and then copy paste inside. Right, and then do the same for the switches. Okay, duplicate. That means you duplicate except for the host name, right? Duplicate these settings for each switches, right? So you can see each switch, right? So that is part one. Part one is basically creating topology and configuring basic settings as given. All right. Then move after you finish those. Okay, should be fast if you have saved the commands before. Just customize it and copy paste. Okay, after you finish that, we go to part two, right? So here is where we're going to apply what we learned about yesterday, which is NAT. So we're going to configure and verify NAT for IPv4, right? Right, so we have here we're going to use a pool of three addresses. That means we have three inside global, okay, three inside global addresses. Okay, we have it in the pool, and whichever host inside your LAN is requesting to, to connect to a host outside of your LAN, then one of the available addresses in the pool will be allocated, and that will be the mapping. The mapping as for the net table. Right, so here basically, since it's first time you encounter net, so the command is basically given to you. You can see there. So try to understand what each of the command does. All right. So creating access list. Okay, so that this access list is used as the set of hosts that is going to be allowed to receive any of the inside global address. As you can see the IP net pool, and the name of the net pool is public access, and you're creating the pool of addresses, right? Okay, yeah. So it says here that the range is that means it's three. Yeah? So 226, 7, and 8. 226, 227, and 228. So it's a range, right? Okay, so after that, configure the translation. So IPNet inside source list one. This one is this one, access list one pool. This associates your access list one with the net pool, right? So inside means this access list is for the inside, right? And then define inside interface, the interface that's facing your inside network. Okay, IPNet inside, and then identify the interface that is facing the outside the internet. Then provide this command IPNet outside. Right. So then you've completed the net configuration here, and then you can test. Right. So this command, remember, is to provide you a list of information about the NAT. You should see something like this. Okay, inside global, inside local, outside global. Remember, only if you are sending message to outside your network will this be will disappear. If you haven't done any messaging, then it will be empty, right? Right. So answer the question asked of you here. Yeah. Then further, you can also try to type this information, as I would call it, information commands lah. Show IP Nat Translation, right? And then I think this one for R1, right? And then try you ping the local interface, loop interface, loop interface on R2 to generate traffic, and then type it again, right? And then try to create again the traffic. Okay, you can ping R2 from S2, right? And then it will fail. Then you get this message, right? So, and here just understand that it's saying that it's expected result because only 3 addresses are allocated. So that means you go beyond already. You go beyond the available because this is pool of only 3 IP IP global. So once you go beyond that, then the other 3 have not expired, so you have run out of IP global address in the pool, right? Okay, so if you want to clear without waiting for the expiry, then just type this command, right? And clear your statistics. Okay, when you finish with part 2, then we learn to configure and verify port address translation, right? Okay, so you in part 3, this part you will configure replace NAT. Instead of NAT, we will replace it with PAT. Okay, to the pool of addresses. So the pool of addresses still there, but now we're going to make use of port numbers because it's PAT. Right? So add the PAT command, of course, remove first, no, okay? Then add the PAT command. So redo it, but now we put overload. Overload is to indicate that it's going to use PAT instead of NAT. Okay, and after that, step 3, test and verify your configuration. Answer these questions, okay, into your Word document. You can use this as your answer also, okay? Right, so then we ping, here we ping, I think we're testing it the same as we're testing NAT before. And we also generate traffic. Okay, try to answer again the questions, right? And then after that, once we finish, as usual, we clear, okay? Clear the translation, that means we're clearing the NAT table or PAT table, and then clearing the statistics. Right, so then we move on to step 4. We remove the NAT pool. Always in iOS is always putting no in front, right? And then use overload for PAT, test and verify configuration. Right. Once you've done that, that is the end of part 3. So you complete until part 3 already. So finally, we want to configure static NAT, right? Okay, static means you manually configure. There's no matching. You definitely want that mapping because maybe you have your own server inside your network, right? And you want that to be stable, so you definitely map that server's IP address, IP local, into IP global. So the means once you create the mapping, and it's supposed to be for long term because later you are going to register that IP global address into the DNS server, so that that IP global address you set using static NAT will be translating to the domain name that you bought for that particular server, right? Because if you don't configure that way, and it's depending on the NAT or PAT to provide the mapping, it can change after expiry, right? From the pool, then it will change. You might be allocated a different IP global, right? Then your DNS, if you don't go and change the entry, will point to a different IP address and doesn't work anymore, right? So this is specifically if you want outside clients to access a server inside your network, your local area network. So by setting it static, sort of become permanent lah, right? This is what you want, right? Permanent mapping. Because, like I say, if you have a server, no one's going to remember the IP address. Okay, that means they will use domain name, the URL. Remember? So, in order for this to work, you need to register the IP address for your server, the global IP global one, with the domain name that you have bought or rented, and then place the entry into the domain name server. Okay, then from then on, whenever someone type the domain name URL, they will be redirected to your server, right? And then because it's static, then it's not changing, which is what you want, because you don't want to keep changing at the DNS every time the mapping changes. We don't want the mapping to change. That's why we have this static NAT. Okay, so this part 4 is to set that and to configure that. All right, so just follow a lot of the instructions the same, like set 1 to clear, the same, yeah. And then this is the one to statically map inside to outside address. Inside local, inside global. Okay, inside local, inside global. Right? Then you test and verify the configuration as usual. And that's it. That's a finish the today's lab. Right? Oh, afternoon, not yet lunch. Okay, Farah. Um, since it's going to go run until 2, it's okay if you want to have lunch while you're doing your work. It's okay, yeah, Vincent, Farah, right? Maybe you want to have your lunch while you're doing your work. It's okay for me, right? Because we finish at 2, so uh, I think it's too late. Maybe for you, maybe you feel hungry. Okay. All right. So, any question on this lab? Because a lot of it is straightforward, and also you basically follow the instruction. So for me, I think it's quite okay lah, straightforward. No question from Farah. How about Noel and Kelvin?
No.
No, no from Noel. Kelvin? Kelvin also no. All right. So this is our lab today. I will monitor. If you have any question at any time, just do that and ask your question. In the meantime, you guys can go ahead and start doing your this lab, right? I will monitor as I said, and I will check in later, okay, to check your progress. Yeah.
Okay.
Okay. All right.
Hi friends, welcome to all. In this video, we are going to solve this lab activity, configure a NAT for IPv4. Before coming to it, friends, if you like to get any CCNA support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get this type of technical videos in future, consider subscribing and don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Okay, now coming back to this activity. Here we can see the topology. We will design this topology in Cisco packet tracer. We have two routers, R1, R2, two switches, S1, S2, and these two PCs. Here we can see addressing table, translation, that is public address 220 in R1. The first address, that is a .225, is assigned to the G0. So coming to our topology, the remaining route is NAT. Two more. We will go to the instructions. Part 1, build the network and configure basic device settings. In part 1, we shown in the topology at packet tracer. We can add then two computers, S1, and this is S2. We will connect these devices. Coming to connections, we will choose copper straight through. From R2, G0/0/0 to R1, G0/0/0. Then from R1, G0/0/1 to this S1, FA0/5. Then we will connect these PCs to switches. FA0/6 to this PC-A, and here FA0/18 to this PC-B. Now let me choose this copper crossover to connect these switches S1 and S2. FA0/1, FA0/1. Coming to step 2, configure basic settings for each router. Okay, we have to assign the device name, though they were enabled. Main lookup. Enable conft hostname R2. No IP domain lookup. Coming to the password settings, assign class as the privileged exit encrypted password. Then you have to assign Cisco as the console password and enable login, and assign Cisco as the VTY password and enable login. Okay, we will do this. First of all, we will do it in R1. Here we will give no. Enable conft. We will set the host name as R1. Also, we will give no IP domain lookup. Coming to R2, CLI no lookup. Then you have to assign Cisco as the routers and set the Cisco in different lab activities. So that's why I'm going a little faster. Okay, now we have to encrypt the plain text passwords and we have to create. Coming to R1, and we will set this. We will repeat this R2. First of all, we will use service password dash h addressing table. We will configure these routers R1 and next is configure interface IP addressing as specified in the table above. Coming to addressing table, we will configure these routers R1 and R2 with this IP address and set to mask. First of all, coming to R1 here, we can see we have two interfaces, G0/0/0 which is connecting to R2 and G0/0/1 which is connecting to this switch S1. So first of all, we will configure this interface G0/0/0. Let me copy its IP address. It's a public IP address, and here we can see it's set to mask. Coming to R1, we will go to that interface that is G0/0/. Zero, and set the IP address with the set to mask. And let me verify it's 240H. Then activate it, no shutdown. Next we'll go to interface G0/0/1. and we will get its IP address. Copy. Also, we can see its subnet mask, IP address, and here is the subnet mask. Activate this interface. Okay. Next, we will go to this router R2. We have this physical interface G0/0/. /0. And also we have this loopback interface 1. First of all, we'll configure this interface. Let me copy this IP address. Coming to R2, interface G0/0/0. IP address, it's here because we already copied it. Then subnet mask, no shutdown. Exit and go to interface loopback 1. We will set the IP address. And here we can see it's a subnet mask. Okay, perfect. Next is configure a default route to R2 from R1. Okay, so we have to go to R1 and we will clear this default static route towards R2. So let me get the IP address of this, it's an next hop address, the IP address of this interface G0/. /0 in R2. We can get that from addressing table. Let me copy that. Coming to R1, exit, and here we will give IP root 0.0.0.0 space 0.0.0.0 space. Then we can specify either exit interface or even we can specify a next hop IP address. Here we will give next hop IP address, already copied it. Okay. Zero dot zero dot zero dot zero space. Then we can specify either exit interface or even we can specify a next hop IP address. Here we will give next hop IP address, already copied it. Okay. Save the running configuration to the startup configuration file. Okay, we can do that. Exit, copy run space start, or even we can give write WR, end, copy run space start. Now coming to step 3, configure basic settings for each switch. That means S1 and S2. Assign a device name to the switch, then disable DNS lookup to prevent the router from attempting to translate. Indirectly enter commands as though they were conf. Next we'll go to S2. The exit encrypted password. Then assign Cisco password Cisco. Coming to S2. Line console 0. Loading. Next is encrypt the plain text passwords, then create a banner that warns anyone accessing the device that unauthorized access is prohibited. Okay, we will give this message. Let me copy this text. So coming to S1, service password dash encryption. Coming to S2, set banner MOTD. Shut down all interfaces that will not be used in these switches. Okay, here we can see in S1 we used the 3 interfaces. They are FA0/5, FA0/6, and FA0/1. So other than these ports, we will shut down. Now we will go to interface as a range, FA 0/1 already used, so we will start from 2, T4, then 5 and 6 already used, FA 0/7 till 24, and also we have 2 gigabit Ethernet interfaces, G 0/1-2, and we have to shut down all these ports. Shut down, perfect. You can verify it. End. Show IP interface brief. Yeah, that's fine. So we can see it's all these unused interfaces are administratively down. Now we will go to S2, and here we can see we used only 2 interfaces in this switch S2, that is FA0/1 and FA0/18. we will go to interface as a range, FA0/2, because 1 we already used, till 17, FA0/19 till 24. Also we got G0/1-2, shut down. Okay. Configure interface IP addressing as specified in that table above. Coming to our addressing table, here we can see S1 and S2. We have to configure IP address to mask for this interface, virtual interface VLAN 1. Okay, no need to set any default gateway. That's fine. So first of all, we'll go to S1. Conf T, we will go to interface VLAN 1. Then we will set the IP address. Let me copy its IP address. And here we can see it's something to mask. Then activate this virtual LAN. Now shut down. Then we'll go to S2. Before that, let me copy its IP address and something to mask. Exit and go to interface VLAN 1. Set the IP address. With the subnet mask, activate it. Finally, here save the running configuration to the startup configuration file. Okay, verify NAT for IPv4. In part 2, you will configure and verify NAT for IPv4. Step 1, configure NAT on R1 using a pool of 3 addresses. Here they given those addresses from 226 till 228. That means 226, 227, and 228. I mentioned only the last, the fourth octet. Okay, don't confuse with that. Now configure a simple access list that defines what hosts are going to be allowed for translation. In this case, all devices on the R1 LAN are eligible for translation. So we are going to create this access list, a standard access list, permit permit 192.168.1.0, then it's a wildcard mask. We will create this access list in this router R1. Password Cisco, enable password class, conf T, and here we will create that access list 1, and we are going to permit this network 192.168.1.0, and we have to specify its wildcard mask 0.0.0.255. Here we did not verify the connectivity, right? And even we did not set IP address for this PC-A and PC-B. So let me set IP address for these two devices, PC-A. Desktop IP configuration. Okay, now default gateway. Then coming to PC-B, we have to give 1.3. I will change it to 1.3. Now just we can test the connectivity. Here I will choose this add symbol PDU option. Then from PC-B to PC-A, here we can see it's successful. Then from PC-B to to R1. Okay, successful. Then from PC-A to R1. Even we can test from R1 to R2. So let me try once more. Successful. We will try from PC-B to R2. So we can see it will fail. We configure a default static route in this router R1 towards R2, but this R2 is unaware of this remote network. That is the reason why we are unable to ping from these devices for R1 towards R2, but you can see it will fail. We configure a default static route in this router R1 towards R2, but this R2 is unaware of this remote network. Single PDU option. Then from PC-B to PC-A, here we can see it successful. Then from PC-B to R1, okay, successful. Then from PC-A to R1, even we can test from R1 to R2. So let me try once more. Successful. We will try from PC-B to R2. So we can see it will fail. We configure a default static route in this router R1 towards R2, but this R2 is unaware of this remote network. That is the reason why we are unable to ping from these devices to this router R2. Now in the remote network. That is the reason PC-B to R2. So we can see it will fail. We configure a default static route in this router R1 towards R2, but this R2 is unaware of this remote network. Route in this router R1 towards R2, but this R2 is unaware of this remote network. That is the reason why we are unable to ping from these devices to this router R2. Now in configuring NAT, create the NAT pool and give it a name and a range of addresses to use. So in R1, we will create this IP NAT pool with this pool name, public underscore access, and then we have to give those 3 addresses they specified from 226 till 228. Then we have to specify the net mask in this router R1. We will create that NAT pool here, IP NAT pool name they given public underscore access. Then we have to give the address 209.165.200.226 space. I will copy this IP address, copy and paste. And here we will change it to 228. Then we have to give the net mask. It's a 255.255.255.248. Perfect. Press enter. We will go through this node. The net mask parameter is not then pool. Then we will specify the pool name. We will do that coming to R1. And here we will give that IP NAT inside source to R1 ACL number 1. what we created. Then pool, then we will specify the pool name. We will do that coming to R1. And here we will give that IP NAT inside source list is 1 pool, then we have to specify the pool name. Just I can copy from here, public underscore access, and paste. Press enter. Again, a note, 3 very important points. First, the word inside is critical to the operation of this kind of NAT. If you omit it, NAT will not work. Yeah, that's fine. Second, the list number is the ACL number configured in a previous step. Yes, we already told. Here we can see that access list will be created with the number 1. Then third, the pool name is case sensitive. So whatever name we given, we created. The same we have to give here also. And they specified it's case sensitive. Define the inside interface, interface G0/0/1, which which is connecting to S1. Then we have to define the outside interface also. That is a G0/0/0. Which is pointing towards R2. We will do that. Coming to R1. First of all, we will give a IP NAT inside. Interface is a G0/0/1, which is connecting to switch S1, right? And we have to give IP NAT inside. Then we will go to interface. You can exit and you can go to interface. Otherwise, you can go from this mode itself. Interface G0/0/0, which is connecting to R2. Here we have to give IP NAT outside. Coming to step 2, test and verify the configuration. From PC-B, ping the loopback 1 interface. So here is the address. Let me copy that. On R2. If the ping was unsuccessful, troubleshoot and correct the issues. On R1, display the NAT table on R1 with the command show IP NAT translations. Then we have to give this command, right? Show IP NAT translations after pinging to this loopback interface 1. So we'll go to this PC-B command prompt and ping to loopback. And we are waiting for the replies. Request timed out. So we are not getting the reply. So it's request timed out. So we have to troubleshoot it. Here we already configured this PCs, PC-A and PC-B. And here we can see we given only this IPv4 address and the mask. We did not give the default gateway. Here we are communicating to the other network. So we must give this a default gateway. So let me verify in the addressing table G0/0/1. Here we can see the address. Let me copy it and we will set the default gateway here. Okay. Same way we will go to PC-B. PC-B is also in the same network. So here is the default gateway. 192.168.1.1. Again, we will test the connectivity from PC-B to this R2 loopback. Go to command prompt, press up arrow from the keyboard, ping 201.165.200.1, and we will wait for the replies. If still it's not working, yeah, it's working. So no need to do any more troubleshooting. That means we configured everything perfectly. Now we will give this show command, show IP NAT translations, so that we can see the translations here. Let me give a show IP NAT translations. So here we can see the translations. They use this inside global 226. Then we can see inside local address, the private IP address. Then we can see outside local and outside global. What was the inside local address of PC-B translated to? Okay, just now we have seen that here. Here we can see inside global, that is a 209.165.200.226. So this is the translated public IP address. What type of NAT address is that translated address? It's inside the global, right? Yeah, we have seen that inside global. Inside global, inside local will show the private IP address. From PC-A, ping the loopback interface 1, that is the IP address of the loopback. Okay, just I will copy that. On R2, if the ping was unsuccessful, troubleshoot and correct the issues. On R1, display the NAT table on R1 with the command show IP NAT translations. So now we are going to ping from this PC-A to this loopback 1. We'll go to PC-A command prompt and let me ping to that loopback 1. And here we can see we get the replies. Now we will go to R1 and we will give that show command again, show IP NAT translations. Just we can press up arrow from the keyboard so that we will get the previous command we entered. Show IP NAT translations, then press enter. Okay, now we can see inside the local address changed. Here we can see inside the global address the same, 209.165.200.226. And also we can see the port number. Coming to this inside local, we can see the IP address of PC-A. Then here we can see outside local and outside global. Notice that the previous translation for PC-B is still in the table, but it was not there. Anyways, we will try once more. From S1 ping the loopback, the previous translation for PC-B is still in the table, but it was not there. Anyways, we will try once more. From S1 ping the loopback 1 interface, okay, on R2. If the ping was unsuccessful, troubleshoot and correct the issues. It will not ping because we did not set the default gateway in these switches. Okay, we will do that. Then we will ping to the loopback 1. Okay. On R1, display the NAT table on R1 with the command show IP NAT translations. So before coming to this ping and this default gateway, so let me maximize this. There, they told that both entries, the NAT entries for PC-A and PC-B should be there in the router 1, right? But we did not see that. So just I will go to simulation mode here. Let me close this. Then from PC-A, let me go to command prompt, press up arrow and press enter. Here we can see ping command. Then minimize it. Then let me go to PC-B, command prompt, press up arrow so that we will get the previous command we entered. We are going to ping to the loopback. Okay, that's fine. So we can see this packets here in PC-A and PC-B. Now just I am going to switch it to real time. I want to test it. Okay, so just I switch it to real time. And now let me go to R1 and let me verify this show IP NAT translations. And here we can see more translations. This is from PC-B 1.2. This is from PC-A, correct? I think so. Let me verify this. Yeah, 2 is from PC-A. This is from PC-A. Yeah, that's perfect. Here we can see now this address is changed. 226 here they used. Here they used the 227. Perfect. Now we can see all the entries. Next we have to ping from S1 to a loopback 1 interface. Before that we have to set the default gateway for these two switches. So let me close this and I will copy this default gateway. Coming to S1. Cisco enable class conf t IP default gateway. I already copied it. Just paste and press enter. I will copy this entire line. Copy. Coming to S2. Password is Cisco enable class conf t and we will paste that command and press enter. So now we can ping from S1 to the loopback. Let me copy the IP address of a loopback. Then coming to S1, exit, ping to the loopback. And the success rate is 80%. That's fine. Now we will give a show IP NAT translations.